Hi, it's Dana, the ingredient inspector, with an investigation on gluten. What is gluten? We're all seeing a lot of gluten-free. A lot of people are trying to avoid gluten. So what exactly is gluten? Gluten is Latin for glue. Gluten is a protein found in the endosperm in the seeds of grass plants. The endosperm is where plants store their proteins to feed on during germination or growth. The gluten that is the focus of food manufacturing is that found in the seeds of wheat, barley, rye, and oats. Oats is a little bit different, and I'll talk about that at the end. These grains are in foods like bread, pasta, cereal, and baked goods. Processed grains have been a part of the human diet for a relatively short period of time. The key word there is processed grains. Wheat gluten in particular is of primary concern since it is the third largest agricultural crop in the U.S. Wheat, that is. Wheat gluten is comprised of or made from 2 of the 4 different groups or classifications of proteins. These are prolamine and glutenin. So a type of prolamine and a type of glutenin form the gluten in wheat, specifically gliadin and glutenin. So gliadin and glutenin are the components of wheat gluten. What does gluten do in food items? So we know it's gliadin and glutenin is what wheat gluten is comprised of, but what does it do? So we add yeast to bread dough to make it rise, and crosslinks are created between the molecules of glutenin and gliadin. The crosslinks form a network which traps the carbon dioxide formed by the presence of yeast, and that's what makes the dough rise. So it adds rising ability and elasticity to baked goods. It helps baked items maintain their shape, and it provides a chewy texture. Are there different levels of gluten? Yes. More glutens are formed in dough when there is more water, more shortening, and more kneading of the dough. Kneading bread promotes the formation of gluten, which results in a chewier texture, as in bagels and pizza crust. Gluten makes pasta chewy and stretchy. Different types of flour have different levels of gluten. So looking at them from those that have less gluten to more gluten, pastry flour, cake flour, and finally white flour. So pastry flour has less gluten than white flour. Less glutens are formed in the dough when there is less water, less shortening, and less kneading, basically the opposite of what we saw up front. Gluten is not digestible by any humankind. The composition is strange. We don't have the enzymes that can completely break down gluten. That's a quote from Dr. Alicio Fisano, the Chief Division of Pediatric Gastroenterology and Nutrition, and the Director of the Center for Celiac Research at Massachusetts General Hospital. There are a couple of words there. Gastroenterology. Gastroenterology is focused on the digestive system. And celiac. Celiac disease is an inherited autoimmune digestive disease that is the result of a direct, severe negative reaction to gluten. There is no doubt, for some people, wheat is addictive. And in some people, it is addictive to the point of obsession. The consequences of glucose insulin fat are especially visible in the abdomen, resulting in, yes, wheat belly. Dr. William Davis, cardiologist, author of Wheat Belly. Cardiologist? Cardiology is focused on the heart. Yes, the bread basket at the restaurant really is addictive. Dr. Christine Ziudrew, National Institute of Health. How many people have reactions to gluten? Celiac disease, which we just talked about as an autoimmune inherited disease, affects 2% of the U.S. population. Gluten intolerance, also becoming known as non-celiac gluten sensitivity, affects roughly 6% of the U.S. population. But gluten reactions, in terms of our bodies having any kind of reaction at all, is all of us. 100%. How much difficulty and damage is involved when we eat gluten determines where we fall on the gluten sensitivity scale. It all depends on how well our intestinal walls close after we ingest gluten and how our immune system reacts to it. Dr. Alicio Fasano. Yes, he did say how well our intestinal walls close after we ingest gluten, and I'll explain about that as we go forward. How do bodies react to wheat gluten? High glycemic index. Wheat is high in carbohydrates and has a high glycemic index. Spikes in blood sugar and insulin. Wheat triggers spikes in blood sugar and insulin levels. Carbohydrates are saccharides, which is the Greek word for sugar. Carbohydrates raise blood sugar. Fat and protein do not. The glycemic index measures the relative response versus pure glucose at 100 on blood sugar level 90 to 120 minutes after eating 50 grams of carbohydrate of a given food. So after you've consumed 50 grams of carbohydrate of a given food, an hour and a half to 2 hours later, what has happened to your blood sugar? And that is the glycemic index. The lower a food is on the glycemic index, the lower the blood sugar level and insulin release, which is considered healthier. So when we look at the glycemic index, we see that whole wheat bread has a glycemic index of 71, and white table sugar has a glycemic index of 68. The point being that whole wheat bread's reaction in our bodies is not very different, significantly different than that of when we consume white table sugar in their effect on our blood sugar levels. Energy source and fat storage. High blood sugar and insulin levels lead to belly fat storage, which leads to health issues. Insulin is an anabolic or building hormone that encourages growth and fat retention. Insulin escorts glucose into cells for immediate energy and then delivers unused glucose to liver and muscles for temporary storage as glycogen. Then the remainder is put in the fat cells for long-term storage. Internal inflammation. Constantly high insulin levels lead to chronic internal inflammation. Inflammation is a biochemical reaction, a protective measure like your body's own mini ambulance and medical team. So some inflammation is good when it's coming in and helping, but to constantly have the medical team present, constant inflammation is bad. An increase in free radicals. Chronic internal inflammation leads to oxidative stress, which leads to an increase in free radicals, which leads to added inflammation and malfunctioning cells, which affects your health. Oxidative stress creates free radicals. Free radicals are unstable molecules that have lost an electron and so are searching for an electron. Searching for an electron for stability, free radicals damage healthy cells and create added inflammation in a continuous harmful cascade as each steals an electron from its neighbor. So this is a very information-heavy page, shall we say. So I've tried to make it a little bit easier by condensing the thoughts here. How do our bodies react to wheat gluten? So wheat is high on the glycemic index. So it's high in carbohydrates, which is why it's high in the glycemic index. And it's high in simple sugars. And these lead to spikes in blood sugar and insulin. So our bodies quickly digest and respond to things that are high in carbohydrates and high in simple sugars. It leads to an increase in blood sugar and insulin release. So wheat is an energy source. Our body uses it for immediate and short-term energy needs, but then what we don't use goes to fat storage. Our body stores the excess as fat. Internal inflammation. Our body is in a state of alert, and an increase in free radicals. Our body is in a destructive mode. How do bodies react to wheat gluten? So it's indigestible. Gluten cannot be properly digested. The protein in gluten is broken down as much as possible by digestive enzymes into smaller units called peptides. Although broken down from their original size, these gluten peptide units are still too large to enter the bloodstream. And something called exorphins form during digestion. Exorphins are opiates in food. Opiates are addictive drugs. Exorphins are termed morphine-like compounds. Increased intestinal permeability. Gluten triggers the body's overproduction of a protein called zonulin. Zonulin regulates the permeability of the doors within the intestinal wall like a gatekeeper. So along our intestinal wall are these tiny little openings, and they open to allow, when we eat food, when it's been properly digested, the little doors open so the particles can go through. So this protein, zonulin, regulates how the doors open and close. So the doors allow only certain things to pass through the intestinal wall or permeate it and enter the bloodstream. The doors allow through properly digested nutrients, those nutrients that have been broken down to the appropriate size. But high zonulin levels lead to increased permeability. It's easier for bad things like the too large peptides and bad bacteria to get into the bloodstream. Internal inflammation. Gluten coats the inside of the intestinal wall, and this limits nutrient absorption by our bodies. The immune system responds by attacking the intestinal wall. It's like, hey, why aren't you letting this stuff through? Something must be going on. Let's check this out. And that leads to internal inflammation. So within 2 hours of consuming gluten, the intestinal wall is damaged, but then it heals itself because our bodies are amazing. But over time, the repeated process of damage, heal, weakens the intestinal wall, and then the sensitivity increases. And this leads to digestive disorders. The immune system becomes increasingly sensitive. This leads to the digestive disorders, and as a result, antibodies form. Antibodies are proteins that your body produces to counteract a specific harmful toxin or foreign substance. Antibodies become elevated to be on higher alert, which leads to increased inflammation. In the case of gluten, the body produces specific antibodies to counteract the harmful effects of the gliadin protein. Gluten is physically addictive. Gluten peptides may enter the bloodstream and cross the blood-brain barrier. The blood-brain barrier shields brain fluids from the circulating blood outside and is also regulated by zonulin. So we have this barrier that keeps our brain separated from the blood and other things that are circulating outside the brain to protect it. gluten exorphins attach to opiate receptors in the brain. Gluten is physically addictive. So opiate receptors are pleasure centers in the brain that can be turned on by exorphins and create a drowsy and euphoric effect. Opiate receptors are the same ones which respond to items like heroin and morphine and other opiates. So our brains are responding to this aspect of gluten, and that is why it is addictive. So again, the summary of these thoughts: it's indigestible. We can't digest it. Exorphins are created when we consume it, and these are morphine-like substances. Increased intestinal permeability, basically that our intestines, the ability to permeate through them in a bad way, is increased when we consume gluten. So it's easier for bad things to get into the bloodstream from the digestive tract. Remember the little thing about the doors opening. Internal inflammation. Our body is in a state of alert. Digestive disorders. We have stomach and elimination problems. Antibodies. Our body is in defensive mode and physically addictive. We have cravings, and when we don't consume it, we have withdrawal symptoms. It has taken nearly 2,000 years to appreciate that a common dietary protein introduced to the human diet relatively late in evolutionary terms, some 10,000 years ago, can produce human disease not only of the gut, but also the skin and the nervous system. Gluten sensitivity can be primarily, and at times exclusively, a neurological disease. Dr. Marios Hadjivassiliou, a recognized gluten and ataxia expert, a consultant neurologist at the Sheffield Ataxia Center. Ataxia? In this case, ataxia refers to the degeneration of the brain due to gluten consumption. So brain damage due to eating gluten. This doctor is an expert in this. Neurologists and neurology are focused on the nervous system. Gluten sensitivity is common in patients with neurological disease of unknown cause. The average American eats 133 pounds of wheat annually. The damage can begin with daily nuisances like headaches and unexplained anxiety, and progress to more sinister disorders like depression and dementia. Dr. David Perlmutter, author of Grain Brain and Brain Maker, neurosurgeon, fellow American College of Nutrition, founding member and fellow American Board of Integrative and Holistic Medicine. Evidence points to the nervous system as the prime site of gluten damage. Dr. Rodney Ford, author of Gluten Brains, The Gluten Syndrome, and Gluten Zero Global, recognized expert on celiac disease and gluten. How do brains react to wheat gluten? So we've talked about how our bodies react, but actually there is a separate discussion to be had about how our brains react. So our immune system becomes increasingly sensitive, we talked about, and this leads to digestive disorders, and this leads to antibodies forming. Antibodies are proteins that your body produces to counteract a specific harmful toxin or foreign substance. In the case of gluten, the body produces specific antibodies to counteract the harmful effects of the gliadin protein. So digestive disorders lead to the formation of antibodies. Anti-gliadin antibodies trigger the immune system to send out cytokines. Cytokines are chemical messengers sent by the immune system, which signal the body to deal with invaders by creating inflammation. Cytokines are generally termed inflammatory cytokines for this reason. Cytokines are most harmful to the brain. They create a high level of inflammation in the brain, which leads to neurological damage or brain damage. So the cytokines. They can accumulate, which leads to added inflammation, which damages the brain tissue. Inflammation in the brain leads to oxidative stress, which activates the production of toxic chemicals and free radicals. Chronic brain inflammation, having your brain inflamed a lot or all the time, leads to malfunctioning brain cells and the narrowing of brain arteries, which leads to neurological damage. So neurological damage. Anti-gliadin antibodies can mistakenly combine with proteins that have a structure similar to gliadin as gliadin itself, which triggers the formation of even more cytokines, which leads to additional brain tissue damage. People with neurological disorders have higher than average levels of brain cytokines. So additional neurological damage can occur as well. Again, the summary chart: digestive disorders, stomach and elimination problems. Antibodies form, which puts our body in a defensive mode. Cytokines are formed, which leads to intense internal inflammation. Neurological damage, the brain gets damaged, and then additional neurological damage, more brain damage. Possible brain disorders. What are some of the reactions associated with gluten sensitivity? Gluten sensitivity can affect any organ in the body and can result in any one or more of the following: headaches, congestion, sore throat, cold bug, movement disorders, skin problems, insomnia, inflammatory conditions, intestinal problems, arthritis, decreased libido or sex drive, chronic fatigue, always tired, depression, compulsive behavior, type 2 diabetes, slight to severe brain dysfunction, nervous system disorders. Which grains are considered potentially problematic with regard to gluten? Kamut, spelt, gram flour. This is not to be confused with gram flour, GRAM, which is from chickpeas and is actually gluten-free. The gram flour we see here is the gram flour used in things like graham crackers. Durum wheat, which is ground into semolina flour, which is also then turned into semolina meal, which is also known as farina or cream of wheat. Bulgur, triticale, rye, barley, malt, like you see in beer. Pumpernickel and farro. These are all considered potentially problematic with regard to gluten. What are other sources of gluten? Gluten is used as an ingredient in things like cosmetics, hair products, pet foods, and medications. Gluten is sometimes found in packaged items like snacks, mixes, spreads, sauces, condiments, imitation meats, ice cream, and candy. Gluten is definitely or likely in these food items: malt flavorings, emulsifiers, natural flavorings, beer, seitan, wheat meat, mock duck, tofurkey, lecithin, vegetable proteins, modified food starch, modified wheat protein, hydrolyzed protein, rennet, yeast extract, maltodextrin. What are some gluten-free options? amaranth, rice, millet, tapioca, which is from the cassava root, quinoa, lupin or lupini, the potato, teff, arrowroot, which we usually see as a powder, chickpeas, and the gram flour we talked about before, which comes from chickpeas, yam, nut flours, flours made from different nuts, sorghum, buckwheat, pure buckwheat, corn, and grits made from corn. Please keep in mind, though, that 92% of U.S. corn is genetically modified. What about oats? Oats are controversial in that they contain something called avenin. Avenin is a protein found in oats that is structurally close to wheat gluten. Avenin can cause inflammation in people with severe gluten sensitivities. This makes oats a food that is cross-reactive with gluten. Oats trigger a response by the body that is similar to the body's reaction to gluten. Often oats contain gluten proteins via cross-contamination when oats are milled in facilities that process gluten-containing grains. So if the oats are milled somewhere that some gluten-containing grain was milled before, some cross-contamination might occur. Oats are transported in trucks carrying or once carrying gluten-containing grains. There might just be a little bit of residue in the truck. Or the oats are grown in rotation with gluten-containing grains. This last point about grown in rotation, many farmers grow crops in rotation, which means a given field is growing a different crop each season. Rotational planting is beneficial because it keeps the soil from being depleted of any single nutrient. For example, a field may grow wheat one season and the next season it is growing oats. As a result, some wheat may still be present in an oat crop. So that's why they're controversial, in that the sensitivity it can be different depending on the source of it, how it was transported or grown, and then that for some people they have that same kind of reaction as they do to gluten found in wheat. Which of these items contain gluten? So this is a question for you now that you're an expert in gluten. When I show you these items, ask yourself, is there any gluten in this? Apple pie, beer, cheeseburger, and a donut. So which of these items contain gluten? All of them. In the apple pie, the gluten could be in the crust, and there also might be some in the filling. Some people sprinkle flour or some other things into the filling to sort of thicken it up a bit. And beer, we talked about, so most beers contain gluten. These days you can find gluten-free beers, certainly, and then also just by the nature of the way they're brewed, some do not contain gluten, but most beers do. And the cheeseburger, gluten in the bun, unless it's a gluten-free bun, of course. And there also may be some in a meatless burger. And in the dough of the donut is gluten. The sources for this video, I'd like to say thank you to and thank you for watching. I hope you feel good, that you've learned something valuable. This is the Ingredient Inspector investigation on gluten, so you can make excellent decisions about what is best for you. The Ingredient Inspector on Twitter and YouTube, and at ingredientinspector.org. Share with the ones you love.